All right, the last one for lesson 7, looking at examples 8, 9, and 10. Surprise, surprise, these were all disk problems. There was not a gap between the region being revolved and the actual axis of revolution. So on the first one, you can see our radius is from the axis of revolution, which is 1, down to the function. The tricky part here, I know maybe we're a little scared, x equals e to the y. How do you get y out of the exponent? Well, you just need to use the natural log. So natural log of x equals y, and if you remember that they're inverse functions of each other, that would really help, wouldn't it? So we're doing this with vertical slices, so everything needs to be termed in terms of x. So our bounds are going to go from 1 to e, and our outer radius here is from 1 to the function natural log of x. And then when we set it up, we just have the integral from 1 to e pi, which I forgot to pull out front, of 1 minus natural log of x squared dx. And since this is a calculator problem, type it in your calculator, you get 1.3715. Example 9. Again, this is a disk problem because there's no gap between my region and my axis of revolution. This time, we're going to have horizontal strips. So my radius is going horizontal, and it's going from the line of axis of revolution, which is 8, and stopping at my function here, which is the cube root. Since this is horizontal, we need everything in terms of y, and so we're going to get x equals y cubed. So our outer radius is 8 minus to the point where that function is, so 8 minus y cubed. No inner radius, it's a disk problem. And we get the integral right here, and we end up with 576 pi over 7, which when you type that in your calculator, should give you 258.5081. And these are all units cubed. I should have been writing that down, shouldn't I? Cool. And example number 10. Again, this is a calculator problem and a disk problem. There's no gap between my region that I'm revolving and the line that I'm revolving it around. So it's a disk problem. There's no holes, no donut holes. My radius goes from the axis of revolution to my function, which is 2 times the square root of x. And since I need this to be vertical, everything needs to be in terms of x. So my endpoints, my bounds are going to go from 0 to 9. I don't have to change anything about the function. It's just the axis of revolution minus the function. And when I set up my integral down here, I'm going to get 54 pi, which is 196.6460. Congratulations! That was our last lesson. It's the last new thing we're going to learn. I might put up optional new stuff later on. We'll see how long this all drags out for. And I hope you guys will email me with questions or ask each other if you have questions.